Okay, time is kind of on a crunch, so doing a 1 hour self-test, that's it. Please, why is the music turning off? The fuck? Cool. An unscoped enum places its enumerators in the scope the enum is in, while scoped enums enumerators must be accessed by via a wall resolving its scope, or using enum name to bring them into scope. What else? Unscoped enum unscoped enumerators implicitly convert to integers and can compared between different enums, while scoped enumerators do not implicitly convert to integers, nor can they be compared different enum types. Convert an enum in enumeration value to a string by passing the enumeration to a function that switches on the enumeration, returning a standard string view with the matching text for each enumerator case. Default member initialization is much like improves safety by preventing use of uninitialized members in the case of value initialization, but in other cases is helpful, like function parameters, default arguments, where a default value is desired, like an enemy with a base health of 100 that can be overwritten. I mean, that's really the point, so it has a default value. I'll take it. just like pass and return structs by reference address, just like other variables, just like other objects. Be the address of by passing an address of and the struct to a pointer, to a struct pointer, to a pointer, to a struct pointer, or by passing the object to a reference. Return a pointer to pointer or reference to a struct the lifetime that exceeds the functions. To avoid dangling pointers or references. Can access the data members in the function, so passing structs via address or reference lets us manipulate or read the values in functions. Access a struct member by the arrow operator or less cleanly by dereferencing the pointer in parentheses, then using the member selection operator to access members. Hold on. Through a pointer, arrow operator lets us chain this too. So if we have a pointer to a struct, and the struct and its data member and a data member is a pointer, we can use struct p data mem struct p member. Instead of a bunch of parentheses and operator this guy. Faster to type and more readable. Overload input-output operators. Operators to easily print structs, which don't convert, well, which standard character output, standard character error are ignorant of without being taught. Makes syntax easier, like standard character output, my struct. Aggregate. Fucking headset. Bro, please. Oh, my water's in the way, that's why. Aggregate initialization of struct aggregate initialization or aggregate initialization of structs is initializing multiple data members at once via list initialization or copy list initialization or assignment. like my struct okay. An L value is an object that variable with a persistent memory address, or rather, it's a named object, while an R value is an unnamed temporary object without a persistent memory address. L values can be referred to after their definitions expression, while temporaries cannot, unless persisted via reference to const to prolong their life. An L value reference is a reference to a modifiable L value, while an L value reference to const is a reference to an L value, modifiable or non-modifiable, or R value. L value references cannot be bound to non-modifiable objects, since the objects are non-modifiable. Since that would violate the non-modifiability of the objects. L value references to const can, because they treat their binding as const, and cannot change them. 10. Declare a pointer to const via data type pointer my pointer address of object. Like const int pointer or constant standard string pointer string p address name. A pointer to a const. To pass a parameter by address. What do you mean pass a parameter by address? To pass by address, we're passing the address of an object known to the caller to a function to cheaply access or to cheaply send its value there for reading, modifying. Pass the address of the object via address object to initialize a pointer parameter. A pointer to the a parameter that is a pointer to the object's type. Standard optional is an object that optionally holds a value. We can evaluate it as a condition or check optional dot has value to see if it has a value. If it does, we can access it via this optional or optional dot value, yielding undefined behavior for operator this accessing if it's empty, and a thrown exception for dot value if empty. This lets us remove the sentinel value problem for cases where all sentinel values are valid return values, and makes knowing if a function failed much easier. Type deduction works by using the auto keyword, which drops references and top level const, like deducing standard string from const standard string reference, because the reference is dropped. Then the const standard string is now a high level const, which is dropped too, yielding standard string. Type deduction doesn't drop low level const. So a const int pointer will never become an int pointer, because pointers aren't dropped, so pointers to const always have low level const, and only the high level const or top level const will be dropped. Turning by reference yields or returns a binding to an object. Make sure it doesn't dangle by ensuring the object lifetime surpasses the function, or exceeds the function, or well, the object is valid. Object won't be destroyed during the function. Returning address returns a pointer to an object, which must be dereferenced to get the value. Both can dangle if the object is destroyed during, well, excuse me, after the call violates. I mean, anything else is different? We must return an address value for returning by address, while we can return an object for returning by reference, which will yield a temporary binding to it, which will return a binding to it if the return type is a reference. 15. A const expression function is one that evaluates at compile time only if, well, if it is passed constant, well, if its arguments passed to it are constant expressions and the function is called in a compile time context. It can still, it will evaluate at runtime if either of those statements are false. Regular functions are only evaluate at compile time if the compiler wills it. Const eval functions must evaluate at compile time, yielding a compiler error. If they are unable to, often due to non-constant expression parameters, arguments being passed. Constant expression functions may evaluate at compile time if both criteria in question 15 are true. See question 15 for my answer. Const expression variables within them must, well, let's see. What restrictions exist on the code inside a const expression function? Code must be executable at compile time. Uh-oh. Cannot result in the const expression. Getting multiple versions of a function would be the same identifier, but unique combinations of parameters and type, count, or order of different types. C++ resolves which, well, determines which function a call is, which overload matches a call, or well, a call, by determining best match. If multiple matches are a best match, it means there wasn't an exact match, since we'd get a duplicate, or well, a redefinition error, since the signatures would be identical. And a conversion that occurred to yield to match and overload yielded multiple best matches, making the call ambiguous. Default arguments are values that function parameters can be initialized, can optionally be initialized with. if the parameter is not given an argument in a call. Default arguments can yield function ambiguous calls because they are omitted in function calls. So overloads with parameter with signatures so if a signature already exists, if a signature for overload B matches overload A with the default argument parameter omitted, the compiler won't know if we're calling the overload without the parameter, or if we're just omitting, or we'll just using the default argument, or by omitting an argument in the call. Function templates enable generic programming, making one function template with template parameters, handling possible behavior in it, and compiling, yielding a separate function instance specialization for each unique function call with its unique combination of arguments. This lets us make one function that can handle multiple data types. 22. A non-type template parameter is a typed parameter included in a template clause like template in X that requires a constant expression initializer or argument in a function call like do thing 5, letting us put constant expression values into functions that we can actually use to initialize constant expression variables, or used to call const eval functions, or const expression functions that need to evaluate at that we want to evaluate at compile time. Function template instantiation is the process by which function template specializations are created by generating a separate version for each unique function, or each function call with a unique argument combination. Assuming the function template uses template parameters. Include function templates in header files. Well, write function templates. So much for fucking. Oh, okay, never mind. Write function templates in header files because the compiler must see their definitions to generate function instances. Function templates have external linkage and are implicitly inline, so the linker will deduplicate duplicate definitions that were generated from separate function template instantiation processes in separate files. Well, from function template instantiation in multiple files. 25. Statement is in single instruction for the program terminated in a semicolon to mark it as a statement, while an expression is any bit of code that evaluates to a result, including variables, literals, function calls, and more. 26. Initialize variables before using them to prevent unsafe, undefined behavior that results from using uninitialized variables. Standard character input extracts character input via the input buffer, while standard character output inserts output to the terminal via the output buffer, i.e. we can acquire user input via standard character input and display input to the user via standard character output. Keywords are words reserved by C++ for type names, exit codes, and other pre-written core words that are used in C++'s core functionality. We cannot use these for identifiers. These include examples include struct, enum, break, continue, int, double, for, while, do, return, etc. White space is ignored by the compiler and helps create readable code. Isn't all bunched, or isn't all jumbled up. White space isn't ignored by standard character input, and it will terminate the character that standard character input is extracting. So if I put some big number space this number, those will be two separate numbers because of the white space. And standard character input would extract the first. Then on the next extraction, discard the white space, then extract the next number. It depends when we're using white space. A value returning function returns a value, while a void function returns nothing. Oops. That's 31. This is 32. This is 30. A literal is, excuse me. It's an unnamed, well, an unstored object. It's an unstored, stored, well, an unnamed unnamed value used once and evaluated, then destroyed. Like 5. C. Hello. Etc. I mean, really. List multiple literals. Okay. For declarations are copies of function signatures terminated in a semicolon, telling the compiler that calls to the function are valid, even though it hasn't seen the definition at the time of the some function call, before some function calls. The linker matches up the definition to the forward declaration, letting us define functions in .cpp files elsewhere, while still using them elsewhere. What is this? Oops. To compartmentalize code and prevent name conflicts. Well, maybe. Well, nah. Oof. Header guards prevent problems by preventing their contents from being included in one file multiple times, which would generate compiler errors if definitions were included in the same file multiple times. They do this by checking if a macro has been defined already, and if it has, the preprocessor doesn't include their code in the file it's included in. Namespace is a sectioned off piece of global scope where identifiers don't conflict with those in other scopes. This lets us use global scope to share functionality across files without cluttering up global scope itself. Isolated pieces of and yielding name conflicts. 5. Syntax errors are language failures mistakes, like forgetting a semicolon, and the compiler will error for them. Semantic errors are meaning errors, using code the wrong way because of faulty assumptions understanding. Let's see. Passing a character object to be modified in a function. But by value, so the character doesn't get modified. 36. A breakpoint symbol, well, is a symbol can place on a line of code, so letting us run code, run all code before, well, letting us stop execution at the breakpoint, step through, over, into it, well, step into, over it, evaluate. Size of, well, lets us get the byte size of an object or data type, or object, data type, or, well, yeah, or data type. Avoid unsigned integers because decrementing them below 0 yields underflow, and they're more likely to yield unexpected behavior. Skipping around now. 39, or what is it? 40? Concise way to represent large, small numbers, like 3E8 instead of 3 0 0 0 0 0 0 1 2 3 4 5 6 7 8. And we use E instead of times 10. So 3 times 10. What the fuck? Where is this caret shit? So the 8 is instead is in 3E8 in C++. Done for now. Okay. Using enum, cool. Using a switch statement to map enum values to strings. Safety, the default member initializers are used when no explicit initializer is provided. Yeah, it makes sense, because if we don't explicitly initialize them, they use the default initializer. Yeah, I thought that was kind of self-explanatory, but it's okay. Object lifetime, yeah, so we don't get dangling. Passing by reference avoids unnecessary copies. Well, it's the same for address and that. It's the same either way. We don't have to say pass by reference or address avoids unnecessary copies, meaning if I copy a standard string into a function, it makes another separate instance of the standard string, and then we copy it back from that. So we get an extra copy of the standard string, instead of just taking the standard string and assigning it to something else. And meaning the copies, meaning moving the information. We would copy it from our initial object to this temporary object, and then we would copy it from that object to something else. Instead, we can just bring the information from where we need, so we can remove one of the copies. Because we need to remove the information at some point, but maybe we don't. Maybe instead of copying it and then using it, we go from 1 to 0 copies. So it always at least removes one copy. The arrow operator and dereferencing, cool. Outputting structs, yeah, it's true. List initialization, designated initializers require super. Well, I have that. That's fine. Aggregate initialization does not allow skipping unless we're using designated initializers. Yeah, makes sense. That's how we do it. That's how I said you do it. Reference to const. Yeah, if we use reference to const, we can get, yeah, that's cool, it's cool. I already said it out loud, or I already said it. You capture the binding rules and the ability to bind to temporary is cool. Example, a pointer to const. Mechanics of rationale, purpose usage, standard optional. Auto drops references and tops, but not low level, cool. Lifetime concerns and the different, yeah, so we don't want to be dangling stuff because we need something like, if we have a variable, we want to make sure that it's a pointer or a reference to a static variable. That way the variable outlives the function, because otherwise if the function call returns and then the variable that we're referencing or we have a pointer to doesn't exist anymore, then we're going to get dangling, we're going to get undefined behavior because we're using a piece of memory that we don't actually have we don't actually have an object there anymore. The value might still be there, but we don't know that, so it's undefined. Compile time evaluation, yeah, that way we can bring stuff from runtime down into compile time. That way, I can take 20 minutes to fucking compile shit for Call of Duty, but I don't have to take every second to do it in the middle of the game. Cool. Constant val does require compile time evaluation. Yep, it'll give compile errors. Yep. Cool. Clear example is not allowed for constant expressions. Yeah, we can't put code inside that doesn't allow it to evaluate at compile time. We can't give it non-constant expression parameters if we wanted to evaluate at compile time, nor can we call it in a if we wanted to evaluate, we can call it in a non-compile time context. It just won't evaluate at compile time, so we won't get the bonuses of using constant expression in the first place. Overload, resolution, and ambiguity. Yeah, exactly. We got different ones. We share functionality. That way we don't have to we can handle different cases. We can disallow specific cases. We can handle different cases differently with the same identifier. A bunch of different things like that. So we could test, like, if it's an unsigned int, maybe we want to still add unsigned ints. We just want to make sure that we're not adding negative ints. So maybe we add a little bit in there. But we don't have to do add uint instead of add int or just add. We could just use add and then do different stuff in the different ones. And the right one will be called depending on the best match. Omitting arguments can cause ambiguity. Yeah, because we have like an int, but one of the ints is a default. The int on the right int is a default argument. But then we have another function called it's just an int, and we call it with just an int. We don't know if we're just omitting the right one and using the default argument, or if we're calling the one that doesn't have a default argument. No idea. Template instantiation. Yeah, it's cool because we can write a piece of code and then boom, it handles different types of input. Don't have to worry about it. Constant expressions, yeah, it's required. We can bring it in. We can use it in functions to pass values that we want to actually put in there and use instead of passing like a reference to it. And even then, I don't even think that might work, might not. I'm not sure. No, I guess not unless it's static. Specializations, yep, created a compile time, blah, 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 match the arguments. Headers, the linker will deduplicate. Oh, cool. All right, that's correct. The linker will deduplicate the duplicate definitions. Nice. I did use pro search. Okay, cool. The risk of undefined behavior. Cool. I can't tell if the AI is just smart today or what. Risk of undefined behavior. Yeah, we don't want to use uninitialized guys. Standard character input to bring input in. Standard character input or output to bring output out. Examples of why keywords can't be used. Yep, sure. Code readability and its input. Examples in a clear definition. Concise and accurate. Cool. Purpose and syntax of 4 declarations. Yep, that way the compiler knows, hey, this guy actually exists. I just haven't seen him yet. It's okay. Multiple inclusion. Careful, DI word, buddy. Expand on namespaces to prevent conflicts. Yes, exactly. So we can put little separate pieces of global scope. That way we can include that in a header file somewhere else. And we can use it. We can put 4 declarations in the namespace. That way we can still define the shit elsewhere. And we're not cluttering up global scope by just putting functions in global scope straight away. Cool. Namespaces, yeah. Syntax versus semantics, just understanding versus fuck ups, and compile caught versus not. Size of to get the sizes. Cool. Underflow for unsigned ints. Cool. All right, notation for scientific notation. Yeah, cool. Good. There's sometimes verbose. Oh, great. Cool. Okay. That was what? 48 minutes? That's it? I mean, that was enough. Honestly, I gotta do a favor for a buddy. It's not even a favor. I told him I would watch something. I'd watch this fucking Chinese anime, and I honestly forgot till really recently. So I gotta watch an episode real quick and then go to bed. All right, cool. Bye.